Okay, as I said, students, our topic for the day is exponents, powers or exponents. What are exponents? Before you get into actual mathematical concept of exponents, it's very important to know what exponents mean or what are exponents, right? So, everyone please cameras on. So, what are exponents? Continued product of a number multiplied with itself. What does that mean? Suppose I take any number, random number, let's say 2, and I keep multiplying 2 to itself, 2 into 2 into 2 into 2 and so on. Suppose I have multiplied it for 10 times. Okay, how can I write it? 2 to the power 10. This 10 is my exponent or power. Okay, so in simple terms, when any particular thing is repeatedly multiplied to itself, any particular number rather is multiplied to itself repeatedly, we can use or bring exponents into existence there. Is it clear? Now, exponents, when you write exponents, let's say if I'm writing 2 to the power 10, this 2, the one which you have repeatedly multiplied, that is called the base. Okay, and the power or the number of times you are multiplying that base, that's called exponent or power. Is it clear? For example, as you can see over here, x to the power 9. How do you read it? X to the power 9 or x raised, sorry, not x to the power 9, x to the power n or x raised to n. Okay, over here, x acts as the base, whereas n acts as the exponent. Am I clear, all of you? So those who did not knew what is exponents, I hope now you know it. Now you at least know what is the definition of exponents. Do you know what is the definition of exponents now? Can you tell? Boys and girls, did you understand? It would be great if I get responses, please. Hello, everyone. Am I audible? Students, am I
Okay, if you
audible?
just repeat. Yes, ma'am.
Okay, so you're not giving any response. Students, be active. Yeah, ensure you are saying something.
Yes, ma'am. Will it be okay if you could please repeat the definition again?
Yeah, surely. I said when you repeatedly multiply a number to itself, Nansha, that's when exponents come into use. Okay. For example, 2. I gave an example over here, 2 multiplied 10 times. So in this case, exponents came into use where 2, the number which was repeatedly multiplying itself, that was the base. 2 was the base. And the number of times it was getting multiplied, that was the exponent of power. Number of times multiplied. Okay, Insha? Is it clear?
Yes, ma'am.
Okay. Now, what are the types of exponents? Types of exponents, negative exponents, exponents with fractions and decimal exponents. As the name suggests, negative exponents. That means when you have negative exponent, like a negative number as an exponent. Like over here, if you see 3 to the power 3 raised to minus 9. Okay, all of you, 3 raised to minus 9. So over here, it's a negative exponent now. What is the meaning of negative exponent? If you remember, in fractions, you have learned something like reciprocal of fractions. Do you remember? Does anyone know what's reciprocal?
Yes, ma'am.
Yes, it's
Yes,
basically
ma'am.
it's opposite. Okay. So suppose I have 3. The reciprocal of 3 is 1 by 3. Again, if I need the reciprocal of 1 by 3, it would be again a 3. Just reversing, twisting it up, down, isn't it? So 3 to the power minus 9. When you have negative exponents now, basically it's the reciprocal of the base. So 3 to the power minus 9 means you first reciprocate 3, that's 1 by 3. The power becomes positive. Once you have reciprocated the base, the power becomes positive. So one more example, suppose I have 1 by 5 to the power minus 4. So this would become 5 raised to 4. Okay. So whenever you have negative exponent, what you need to do, you just need to reciprocate the base and the exponent turns to a positive exponent. Understood, all of you? Understood? A quick nod if you understood.
Yes, ma'am. Yes, ma'am.
Good.
Understood.
Next comes exponents with fraction. Again, as the name suggests, where you have fractions as exponents over here, as you can see. Okay, 5 to raised to 2 to the power 2 by 3. 5 raised to 2 by 3. In this case, what you can do, you can convert it into a unit fraction, 1 by 3. You leave the denominator, you bring the numerator inside. It becomes 5 square to the power 1 by 3, or 5 square means 5 multiplied 2 times, 5 into 5, that is 25 raised to 1 by 3. Okay, you don't have to panic. These are just the, this is just a brief. When you study in regular classes or when you study the chapter in details, you get to know more about it. Okay, this is just a brief. This is just a, slight view of what are types of exponents. So you don't have to panic. Over here is just a small intro. Is it clear, all of you? Next comes
Yes, ma'am.
decimal exponents. Decimal exponents, again, the same thing where you have decimals as exponents. So 1.5, if you have 4 raised to 1.5, 1.5 can be written as 15 by 10, na? Yes or no? You can convert it into fractions. And once you have converted into fraction, you can switch to exponents with fractions. Isn't it? Isn't it?
Yes,
Yes,
ma'am.
ma'am.
Yes. So these are the 3 types of fractions: negative, with fractions, and with decimals. Okay. Now, the entire exponent chapter is basically dependent on this very slide. The one which you read earlier just before this, the types of exponent, that really does not matter a lot. That is important, obviously, that's a part of your syllabus. But this is the most vital part of the chapter, that is laws of exponent. If you know these laws, you are done with 75% of your chapter. Okay. So what are the laws of exponent? The first law states x to the power m multiplied to x to the power n. Suppose you have the same base under multiplication. You have the same base under multiplication. What you do, you just add the exponents or the powers. The base remains same. You just need to add the power. Similarly, same base under division. Same base with different exponents under division, you subtract. I repeat, same base with different exponents under multiplication, you add the exponents. Vice versa, same base under division with different exponents, you subtract the exponents. Am I clear?
Yes, ma'am.
Next, if you reverse, over here the base was same, over here the exponent is same, but the base is different. What do you do in that case? When the exponent is same, but the base is different under multiplication, you multiply the base. I repeat, when the base is same, you add the exponent, but when the base is different and the exponent is same, you multiply the base. X into y, the exponent remains stagnant. Understood? Similarly, different exponents, sorry, 2 different exponents and 2 different bases under division. Okay? X by y, let's say any base, x by y is your base, and you have n whole to the power m. In that case, if you have 2 exponents, you multiply both of them. For example, let's say 2 to the power 2 whole to the power 3. What will it become? That would be equal to 3 into 2, 6. So it becomes equal to 2 raised to 6. Do you understand? I don't expect you to understand
ma'am.
all in one go. Okay, I know it's not possible. Those who are learning for the first time, it's not obviously possible to just fall into it. But yeah, I can expect you to keep something at least in your mind, right?
Yes, ma'am.
Next, negative exponent scenario. What do you need to do? You reciprocate the base. So x by y becomes y by x, and the exponent becomes a positive one. Okay. Next, anything raised to the power 0, the value is 1. For example, if I have 2 raised to 0, the value is 1. If I have 4 raised to 0, the value is 1. Anything to the power 0 stands for 1. And anything to the power 1 stands for the base itself. Okay, for example, if I have 5 raised to 1, it would be 5 because it denotes 5 one time. So 5 one time is 5 only, now 5 one time is 5 only. Yes or no?
Yes, ma'am.
So anything raised to the power 0 is 1 and anything raised to the power 1 is the base itself. Okay. Lastly, again, a negative, exponent scenario. X raised to the power minus 1 is nothing but 1 by x. Because it's minus 1, so it would be x only. So, but 1 by x because it's a negative 1. Okay, boys and girls. Seerath and Insha had a bit of, idea of exponents. What about the boys? Saksham, Manish. Your name is Saksham?
Excuse me, ma'am.
Yes, Insha.
What if the base and the exponents are different? Both are different.
What if?
Both the exponents and the base is different.
Both the exponent and base is different, then you have to solve them individually. For example, let's say 2 raised to 2 and 3 raised to 3. Okay, both base is also different,
Yes, ma'am.
exponent is also different. In this case, you need to solve them individually. 2 raised to 2 means 2 into 2, 4. Multiplied to 3 raised to 3 means 3 into 3 into 3. That makes it 27. 27, right? 3 3s are 9, 3s are 27. Now you multiply 4 and 27.
Okay, ma'am.
Okay.
Yes.
When you have nothing in common, you proceed individually and finally you perform the mathematical operation that is originally in the question.
Thank you, ma'am.
Okay, everyone. You're most welcome. Manish, Ankit, do you understand? Your name is
Yes.
Sarthak or Saksham? Which one? You're on
Yes,
mute,
ma'am.
Beta. You're on mute. Your name is Sarthak, right? Okay. Seerath, understood?
Yes, ma'am.
Okay. Moving on to our scientific notations with exponents. Okay. See, exponents chapter is a small chapter. Originally, also it's a small chapter. It's not like in demo we are having it small. It's somewhat comprising of this much heading only. It's just that you need to know the laws properly and you are done. So scientific notations, what do you mean by scientific notations? They are actually the standard form of writing very, very large numbers. Okay. Any number can be written in scientific notation when it is between 0 to 10. For example, what you need to do is see how do you write scientific notations. First step, there are 2 steps that you follow. First step is you put the decimal point after the first, listen to me very attentively. You put the decimal point after the first digit from the left. If there is only 1 digit in the number excluding zeros, then you do not use decimal. For example, let's see over here, I have one number 56 and 4 zeros, that makes it 5,60,000, right? What does my first step do? After the first digit from the left, I introduce a decimal. So it becomes 5.6. Okay. If the number would have been 5,000 just, only 1 digit leaving the zeros, then you do not use decimal. If without the zeros, you have more than 1 digit, you use decimal, otherwise you don't. Okay. And how do you use decimal? Just 1 digit after the digit from the left, first digit from the left. Okay. Now, next step is you need to multiply that number with a power of 10 such that the power will be equal to the number of times you have shifted. For example, if I introduce decimal over here, how many times I have to shift? 1, 2, 3, 4, 5. Then I would come to the end now. So the scientific notation of the number becomes 5.6 multiplied to the base is always 10. 10 raised to how many times you have shifted? How many times shifted? 5. So it becomes 5. Do you understand, all of you? Did you understand?
Yes. Yes, ma'am.
Sure? Okay. So here is one sum. Find the value of the given. See, the first one, 6 raised to 3 multiplied to 6 raised to 2 divided by 6 raised to 5. First, you use the law where you have same base but different exponent. So it would become 6 raised to 3 plus 2. You add, right? That makes it 6 raised to 5. 6 raised to 5 divided by 6 raised to 5. Second law of exponent. Same base, you subtract. Same base under division, you subtract. 5 minus 5 becomes 0. So 6 raised to 0. Anything raised to 0 is 1. So my answer is 1. Do you understand how to solve the sums?
Yes, ma'am.
Yeah.
Understood.
Next one. Which of the following statements is correct? See, if you observe, all the bases are same. 5 by 4, 5 by 4, 5 by 4. So you can add the exponents now. 5 plus 11. And if you make the equation, 5 plus 11 would be equal to 8x. Yes or no? As per the algebraic expressions. Correct? Left hand side is equals to right hand side now. So if you just ignore the base, 5 plus 11 would be equal to 8x. Correct? That makes it 16 is equals to 8x. So what is the value of x? 16 divided by 8. That's a 2. Yes, all of you? So x
Yes,
is
ma'am.
equals to 2. That means my statement is correct. Similarly, over here also the bases are same. So you can ignore. That leaves me with 3 plus 7 since it is under multiplication. 3 plus 7 is equals to x minus 1. So 10 is equals to x minus 1. So x is 10 plus 1, 11. Correct? So x is 11 over here also. That means both of them are correct. Right, all of you?
Yes.
Yes or no? Yes?
Yes, ma'am.
Okay.